Hey everyone, welcome back to your channel Technology Incroyable. Today we will look into the problem number 15 from LEETCODE, that is 3 sum. So let's quickly read the problem statement. Given an integer array nums returns all the triplets such that indexes are not same and nums of I, nums of j and nums of k. The sum of all the three numbers should be equals to 0. And notice that the solution set must not contain duplicate triplets, so output should not have duplicate triplets basically. So here are some examples they have provided. Here input array and the output does not have any duplicate triplet basically, and the sum of all the triplets value should be equals to 0. And another example and look into the constant also, like length of the nums are between 3 to 3000 and nums of I is from minus 10 raised to the power 5 to plus 10 raised to the power 5. So these are some constant. So let's look into the problem statement. So this is our array, and this is how we need to return the output, all the combination of three numbers such that the sum is 0. So if we try to go for the brute force, then we need to search all the combination of three numbers 1, 2 and 3. So if the length is n, then the, n cube, there should be this many combination could be possible, and for finding all the possible combination we need to go for we need to add three nested for loop, and the time complexity will become O of n cube. Okay, and this is not at all efficient, so we need to find some better solution for this problem statement. So earlier we have seen the two sum problem, in which we need to find the two numbers such that the sum of the two numbers is equals to a target value. Basically a plus b equals to target value. So can we but in this case the array was given as a sorted array. Okay, so they're 1 4 6 array was given sorted. So in that case, if the sorted array is given, then we can think of two pointers. One pointer is pointing to minimum value and other pointer is pointing to the maximum value. So can we convert this problem into two sum problem? And for two sum, first we need to sort the array. So let's try to sort this array. So I have sorted this array, and then what we need to do, we need to find the combination of three numbers such that the sum is getting 0. So why I am saying that can we think of it as a two sum problem, because the problem statement for this three sum is 3a plus b plus c is 0, and two sum problem was what, b plus c, sum of two number is equal to a target value. So can we say that b plus c is equals to minus of a, right? So it is looking similar to this problem only, two sum. So let's try to solve it in this way. So in this way the time complexity will be O of n square, because we have solved this problem in O of n only earlier. And for another because if we want three combination, then two numbers we will get from here, but for one number we have to still iterate. So I am fixing a value of I, and then I am finding the value of other two numbers from b and c from this value. So for iterating a value of I need n, and for this particular finding two numbers I need extra n. So total will become O of n square. So let's try to think with this example. So let's look. This is my value of I, my first number a. This is my value of j in this case, which is I plus 1, and this will be value of k. This is the last number. Okay, so in this case what would be our combination? First number will be minus 4, and we need to find the another two numbers, right? So another two numbers from this between I to k. So let's try to find this another two numbers. So suppose minus 1 plus 2, this value is 1 and a target value will become 4. In this case our target value is 4. Are we getting the target value? No. And target value is basically 4, and which is greater than this number. Okay, so we need to increase this value, increase the value of this sum. So for that we have to increase the value of j, the first pointer. So here you can see that value at j are same. So again we need to increase the value, because we didn't found any number with that particular value, and we also don't have to add the duplicates, because it's given that if still we found a number with that combination with that, but we don't need duplicates, triplets in the with the same numbers. So we have incremented, and now j came to this point and pointing to 0. So still k is at 2, so 0 plus 2, which is 2, and 2 is still less than 4. So still it's not equal. Then we again increment the point j pointer, and now it's 1 plus 2, but 1 plus 2 is still less than 4. So for this case we didn't found any combination which sums to 0. Okay, so let's increment our I pointer and find the next combination. So now my I is pointing to this value, and I need to search the next two numbers from this value. So j will point to I plus 1 and k will point here. Okay, so here our next combination will become minus 1 and another number and another number, right? So what we need to do, we need to find the two extra numbers, because minus 1 is now fixed. So let's try to solve this problem. Like first number is minus 1 and the last number pointing which k is pointing, which is plus 2. So it is plus 1, and our target value here, because first number is minus 1, so target value is 1, and this is equals to target value. So we can add this combination minus 1 and 2 in our output list. Okay, so we found out one combination. So now we will increment the I pointer, right? So does this now I is 0 plus 2, which is equals to 2, and our target was 1. So it's actually greater than 1, greater than our target value. So I will decrement this pointer, k pointer basically. Now I will try to, like my j is still pointing here only to 0, so 0 plus 1, and it is again getting equal to 1, which is our target value. Okay, which is our target value. So now I have found out another pair, another triplet basically, which was minus 1 was fixed, and another one was this 0 and this one, 0 and 1. So this is also the sum of this triplet is also getting 0 only. So like this we have to we have converted this problem into two sum problem, and we have solved this in O of n square only. Okay, but brute force will take O of n cube. So let's look into the solution also. What we have seen for the solution. We have written the solution here in Python. So first we have sorted the array, and then we have created an empty result list, and then we are iterating for all the I values, and if I value is greater than 0, and if there are any repeated I value, because we need to avoid the duplicates, so I am continuing. If the last I value is already covered, then there is no need to again iterate for that particular combination. Then again if j for I need to start one j pointer and one k pointer. So j will be I plus 1 and k is the last value. and this is our two sum problem. So until j is less than k, we are finding out the sum, and if sum is less than 0, we are incrementing the value of 1, because we need to increase the value, because sum is less than the target value basically. And if sum is greater than 0, then we have to decrease the value of sum. Then for decreasing, we need to decrease the k pointer, and at the end, like if these two conditions are not met, that means that sum is equals to 0, and that was the desired, so we appended in the output list. And then again we have incremented the j pointer, because we need to find another combination, and then we are checking that j value, the current j value and the previous j value is both j value are equal. Then we are again incrementing the value of j, because we need to avoid the duplicates here. So that's how we have solved a problem. Let's try to submit this solution. I have written the same solution here. I have submitted it earlier also. Let me submit again. So you can see that all the test cases have been passed, and it's accepted.